We are going to balance the following chemical equation. Butane reacts with oxygen to produce carbon dioxide and water. First, we are going to check if this chemical equation is balanced. How many carbon atoms are there in the reactants? The reactants are here. They are butane and oxygen. The number of carbon atoms is 4 in the reactants. Try to fill in the rest of the gaps. We observe that the number of atoms of carbon, hydrogen, and oxygen is different on both sides of the equation. As soon as one of the atoms is not balanced, we can say that the equation is not balanced. For example, the number of carbon atoms in the reactants is 4, but the number of carbon atoms in the products is 1. So we can say that this equation is not balanced. Second, we mark the positions where we can put stoichiometric coefficients, but be careful, only in front of the formulas. We can't change the subscripts, that is, the numbers within formulas. Third, we start by balancing the atoms that appear in a single formula of the reactants and the products. We usually start with atoms other than hydrogen and oxygen. In this case, we start with carbon atoms. Read the following text and try to fill in the gaps. Since there are 4 carbon atoms in the reactants and 1 in the products, we place the number stoichiometric coefficient. Try to answer the question. 4 in front of. Try to answer the question. Carbon dioxide. Thus, the carbon atoms are balanced, 4 carbon atoms in the reactants and 4 carbon atoms also in the products. Four carbon atoms in the reactants and 4 carbon atoms in the products. So we can say that carbon atoms are balanced. Read the following text and try to fill in the gaps. We now proceed to balance hydrogen atoms. There are 10 hydrogen atoms in the reactants and 2 in the products. Therefore, we put the number coefficient 5 in front of the water. What is the coefficient here? That's right, the coefficient here is 5. Read the following text and try to fill in the gaps. Now we have two atoms of oxygen in the reagents and 2 times 4 plus 1 times 5 equals 13 oxygen atoms. Now we have 2 atoms of oxygen in the reagents and 13 atoms of oxygen in the products. We must put a number coefficient in front of oxygen so that 13 oxygen atoms also appear in the reagents, but no integer multiplied by 2 gives us 13. In these cases, we should think about using a fractional number. This fractional number is 13 halves. What is the coefficient here? That's right, the coefficient here is 13 halves. Read the following text and try to fill in the gap. Since the equation has a fractional coefficient, we multiply all its coefficients by the least common multiple, LCM, of the denominators of the coefficients. When there is only one fractional coefficient, or if there are several but all have the same denominator, the LCM will be that denominator. In our case, the LCM will be, try to answer the question. That's right, the LCM will be 2. By multiplying all the coefficients by 2, we will get all the coefficients to be integers, that is, whole numbers. Now we have obtained the balanced equation. 8 carbon atoms in the reagents and 8 carbon atoms in the products. 20 hydrogen atoms in the reagents and 20 hydrogen atoms in the products, and 26 oxygen atoms in the reactants, and 16 oxygen atoms plus 10 oxygen atoms equals 26 oxygen atoms in the products. So we can say that this equation is balanced. This is the end.